Hello everyone, welcome to the first workshop of the Advanced track. Today we'll be covering Game Programming Essentials. This tutorial is brought to you by ACM Studio at UCLA. Here's a quick overview of what we'll be covering today. First, we'll be discussing best practices for game programming, including encapsulation and information hiding, code readability, and building and playtesting. Then we'll dive into a series of useful C# and Unity features with a hands-on project. These features include coroutines, the static keyword, player prefs, properties, events, and attributes. And finally, we'll close off with a quick section on using console and debug. So let's get started. What is encapsulation? So one of the main problems, not only in game programming, but other programming disciplines as well, is that implementation details of your code are likely to change over time. When you make changes to, for example, your player controller script, you don't want to have to change code in other dependent classes like the UI, camera, or inventory. Therefore, we want to use the principle of information hiding, in which we only allow access to details other code that actually needs. Ideally, your other code should be able to treat one class as a black box, so that even if the implementation inside the black box changes, you don't have to make any other changes outside of that black box. Here are some tips to help you achieve encapsulation when you code for games. So before you code, the first and most important thing is to actually think about what is likely to change and how to protect external code from those changes. Thinking about this before you code is extremely important because changing your design after you code can take a lot of time and effort. Interfaces are basically a specification of an API that your code will follow. By using interfaces, you can ensure that your code doesn't reveal more implementation details than it needs to. In addition to encapsulating entire classes, you should also think about how to encapsulate some of your larger functions. In many of these larger functions, changes to one part of the function will also require you to change other parts of the function, which is why it's a good idea to also think about how to decompose these larger functions into smaller ones. If you can extract some of the functionality out into a smaller function and simply call that smaller function in another function, this will help you reduce the amount of code you have to change when you make implementation change. Then, while you code, you can also explicitly mark every single variable and method as either public, private, or protect. This has two benefits. First of all, it makes it very clear what is and is not accessible from inside and outside of the class. And second, whenever you mark a variable or method as public or private, it forces you to think whether you actually need to make this variable or method public or private. A second tip is to use wrapper functions. Wrapper functions are essentially functions which call another function with only minimal computation or changes. Wrapper functions are very useful because they provide a layer of protection between implementation and usage in other classes. And also, they can help simplify your code. For example, if 90% of the time you're going to be calling function A with the same parameters, you can write a wrapper function around function A that uses those parameters. Finally, you can break methods that become too large into smaller ones. Even though you might have designed your code beforehand, sometimes as you write your code, you find functions that are larger than you expected them to be. And you should still try to decompose these larger functions into smaller ones. Our next topic is code readability. In terms of code readability, you want to be able to read both your own code and other people's code. So you want to adopt a shared code style so that it's as easy as possible for you to understand each other's code when you're working with other programmers, which is often the case in video game development. Some particularly important parts of a shared code style include consistent indentation, which helps highlight control flow, and a consistent naming scheme, which can help differentiate between variables and methods and their level of accessibility. Related to this is using informative variable and method names. Whenever possible, don't use variable names like I, J, N, M. Instead, you should attempt to use variable names that actually describe what that variable is. Ideally, these variable and method names will be informative enough that you won't even need comments to understand what they represent or what they do. Nevertheless, you should still write informative comments because these help reduce the amount of time required to closely read through your code and understand what's happening. And of course, don't forget to update the comments that you write as you make changes to your code. Alright, finally, let's cover best practices for building and playtesting your game. First of all, you should be playtesting your game continuously throughout development. There's nothing worse than finding out that there's a major bug in your game at the end of your development cycle, and that fixing that bug would require rewriting entire systems of your code. So by playtesting throughout your development cycle, you can help catch these nasty bugs early before they require a lot of work to fix. Along these lines, you should also make playtesting easy so that playtesting isn't a chore. For Unity in particular, you should make sure every single scene is playable both by itself and in sequence. This is because some bugs only manifest when you play, for example, scene 1 and then scene 2 in a row, especially when you have do not destroy on load objects. While other times you will want to play a specific scene to test for bugs in that scene without having to play through all the scenes that come before it. You should also add debug keys, such as pressing the equals sign to skip content. This allows you to skip certain parts of a scene in order to test other parts of that scene more quickly. Finally, you should build your game early and often. Even though most of your playtesting can be done in the Unity editor, building your game for all the different platforms and screen resolutions you plan on supporting can help catch platform-dependent bugs, especially with WebGL. Also, it's a good chance to test whether your UI appears how you want it to on different screen resolutions. Plus, building early means that you will work through any obstacles that you might encounter with building your game for specific platforms, so that at the end you'll definitely have at least something to present, and also building your final build won't be a rushed, stressful event because you've already done it many times. Alright, now let's move on to the hands-on portion, where we'll be making a dialog typewriter effect plus a settings to control the text delay for this typewriter effect. Here on the left, you can see this typewriter effect where it pens a character at a time. Let's open up the Unity project, and here you can see I have a typewriter script and it's attached to this TextMesh Pro component. So if we play the scene, it will show a message one character at a time. So are we done? No, because let's take a look at this typewriter script. Take a moment to read and understand what's going on in the script, pausing the recording if necessary. So even though this typewriter script is functional, we do need to see that there are quite a few problems with this script. First of all, the typewriter effect always starts at the start of the scene. There's no way to trigger it later at a specific time. Second of all, there's no way to run the typewriter effect multiple times, even with different lines. Although we could add functions to reset these variables or change the example line to display, this requires a lot of additional code and also is poorly encapsulated because you need to understand the implementation of this typewriter in order to make those changes. To help solve some of these issues, we'll turn to coroutines. So coroutines are a Unity feature which allow you to pause execution of a function and return control back to Unity. And then Unity will then resume this coroutine at a later time. So coroutines are a type of function that return IEnumerators, which are a special type of C# object. You don't need to know what IEnumerators are to use coroutines, but if you're curious, you can read the C# documentation. So inside of your coroutine, you use a yield return X statement, where X is one of these items listed below. So for example, yield return null will pause your function until the next frame, and yield return new wait for seconds will pause your function for some number of seconds that you provided. You can also use yield return and then another coroutine so that you can start another and wait for that other coroutine. Finally, Unity allows you to code your own custom yield instructions to allow your coroutines to wait until a specific event happens. From inside of your coroutine, you can also end early by using the yield break statement. To start a coroutine, use this start coroutine function, and you can also stop coroutines using the stop coroutine function. So let's convert our typewriter script into a version that uses coroutines. Here we're going to make our coroutine, and let's call it Typewriter to describe what it does. And in the interest of flexibility, we can have it take a string. Let's call it display line, and that's the line that it will display one character at a time. And then so we will no longer need this example line. Okay, so the nice thing about coroutines is that we can convert some of these class members into local variables. So for example, we can loop over each character in display line instead of keeping track of how many characters we've already displayed. And we also don't need to store the string builder as a class member. Instead, we can have it as a local variable. So for each character, we can append it to the string builder and then update. Now here, since we want to pause between each character, we want to do a yield return new wait for seconds. And in this case, we want to wait for this delay. One thing to note is that if the delay is 0, we don't want to yield and return control to the Unity. Instead, we just want to finish this for loop. So if delay is greater than 0, then we will yield. So now we no longer need this code inside of update, nor do we need to store the amount of time since the line was last updated. Instead, we can start the coroutine from here. Okay, apparently we can't have typewriter be a function of typewriter, so let's just rename it to be typewriter coroutine. So now if we click play, we see that this example line shows with the typewriter effect at the start of the scene. So the nice thing about this is that we can start this coroutine at any time, not just at start. So for example, if we write up a wrapper function, let's say start typewriter, we can then, for example here, create a UI button and have it call that start typewriter function with a different. So now every time we click the button, this typewriter effect happens. There is one issue with this though. If we try to click the button too quickly, you may see that the text inside of this text box gets messed up. This is because even though we started a new coroutine, the previous coroutine is still running. So we do need to actually stop the previous coroutine before we start the next one. To do this, we can store the coroutine as a private variable inside Typewriter. Let's just call it ongoing. So we can store this. So start coroutine returns the coroutine that it starts. So we can store that into ongoing. And then before, if ongoing is not null, we can stop that coroutine. So now we stop the coroutine, the previous coroutine, before we start the next one. And I hope you see why these wrapper functions are very useful for preserving encapsulation. Because otherwise we would need to make sure that our other code doesn't call the coroutine too many times in a row. So now you see there's only ever one coroutine running at any given time, and therefore the different coroutines don't compete to edit the same text. Alright, so I've already listed some of these benefits earlier, but here are them again. Coroutines can be called multiple times very easily. We can now use different input strings for our typewriter effect. We've converted several class members into local variables, which makes our class less complicated and reduces namespace pollution. And finally, the code is just simpler and easier to understand. Here's some other neat tricks you can use with coroutines. For example, you can run coroutines in parallel by starting them in a single function, or you can run them consecutively by inside another coroutine, shown in run in sequence. Here we yield return start coroutine 1, and then after coroutine 1 finishes this, we run the next line, which is start coroutine 2, and therefore we do coroutine 1 and then coroutine 2. If you'd like to read more about coroutines, here's the link to the Unity documentation about them. Here's a pop quiz. What does this coroutine do? Take a moment to think about this, pausing the recording if needed. Okay, so first, we start running these coroutine 1 as coroutine A and coroutine 2 as coroutine B at the same time. So this part is in parallel. Then we wait for A to finish and then for B to finish. So in essence, coroutine A finishes first, then we wait until coroutine 2 finishes. If coroutine 2 finishes first, we wait for coroutine A to finish, and then we immediately see that 2 is already finished. So therefore, this entire function runs these two coroutines in parallel and waits for all of them to finish. Alright, so our typewriter effect script is nice and all, but what if we want the player to be able to change the text delay at runtime? In fact, what if we have multiple typewriter effects in our scene and we want to change them all at once? And also, what if we want to change this text delay and have it be persistent between scenes? So we can use the static keyword to help us solve these problems. So if you have taken CS classes at UCLA and used C or C++, you might already use the static keyword before. However, I'd like to emphasize that the static keyword in C# has a subset of the meanings it does in C and C++. In particular, in C#, static can be used on class members to indicate that those members belong to the type or class, rather than a particular instance or object of that type. So, for example, if we have a car class with a static number of wheels, or max number of wheels, then all instances of car will have the same max number of wheels, whereas each car can have a different number of wheels. So static members can be accessed with the type name instead of the name of an instance of that type, and different instances share the same static variable. You can also mark methods as static, and so because these methods are static, they can only use static variables, and they can't use non-static member variables. So in our car example, a static method could use the max number of wheels a car can have, but it would not be able to use how many wheels a particular car has. You can also mark entire classes as static. Static classes consist of only static variables and methods. As a result, they cannot be instantiated and are instead globally accessible. You may have already used static classes, such as in many languages the math classes are static. Okay, so for our next trick, we can create a static settings class to hold our text delay. Note that this settings class does not inherit from mono behavior because we actually don't need all of the extra features of mono behavior just to hold this single float value. So let's go back to our scene and create a new script called settings. Open it up. So we don't need to inherit from mono behavior, and therefore we can't use void start and update functions. It's static, and in this case we want it to be globally accessible, so we'll make it public. And we can set a default value here. So now in our typewriter class, instead of storing this delay, we can just go here and say settings.textDelay. So here, this settings is type name and text delay is the static variable of that type. Oh, I forgot to. So if we run this, you can see that it still works as before, except now if we changed the value stored in settings, any copies of this typewriter script will also be changed. Let's create a UI slider to demonstrate that, and let's add a new script as well. So let's call this a text delay slider. First of all, we need to store the slider. So sliders are part of the Unity engine.ui namespace, so we need to use that namespace. So then now we can store a reference to the slider. So awake is sort of like start, except it happens before start, so that you can initialize things that are will be on your game object before you go and find other things elsewhere in start. So we can just go and get component slider. So at start, so during awake, we want to set the value of this slider to be the text delay that we had. Okay, and now we need a public function to change text delay. So we can just set settings.textDelay to the delay. So as you can see, I forgot. So here we also needed edit the sliders on value changed and add a listener. So we can add this change text delay listener. So now if we attach our script and also move the slider down slightly so it's not covering the button. We also need to change the slider a little bit because we want it to be right to left because we want the right to be faster. So at the right, our text delay is 0, which means it's instant. And on the left, we don't want a whole second between characters. Let's do a tenth of a second instead. Okay. Now the slider should be more reasonable. Yes, so now if you see, this displays instantly. If we move it all the way to the left, it displays very slowly. And we can also even move the slider while it's printing to change the speed of the typewriter effect. Okay, so now I didn't show you, but settings will store this value of text delay between scenes because settings doesn't inherit from modern behavior and therefore isn't destroyed between scenes. And it just continues storing that variable. However, whenever we start the game, the value of text delay will be reset. So we can use player prefs to store values between game sessions. Player prefs is a Unity class that stores ints, floats, and strings into a text file well, it's not a plain text file, but into a file on your computer, so that whenever you play the game, player prefs can then read from that file and write to that file. And therefore, these settings, things like settings, can be saved in player prefs for another game session. So for our settings script, we're going to use player prefs.setFloat and player prefs.getFloat. So setFloat is pretty self-explanatory, and getFloat, there's this default value so that if you try to get a float corresponding to the key name to a key name that isn't already stored, you can get a default value instead. Similarly, there's player prefs.setInt and getString. However, if you think about this, there's an issue with changing to player prefs, because player prefs we have to call these functions to set or get our text delay, which means we can't just reference it using settings.textDelay. Except C# has a handy feature called properties. So properties are like variables, except they have codable getter and setter functions. So here below is an example of a property, and so you can create properties with just get and set, and Unity or C# will automatically create a hidden backing field for example, float, and then automatically get and set that from the hidden field. But you can also write your own code to, for example, call player prefs. Also, properties can be used to allow for like read-only variables by having a public get function but a private set function. So let's go and edit our settings to use player prefs instead. So first we have get and set, and now we can specify exactly how we want to get and set. So when we get, we want to return player prefs.getFloat, and we can just use text delay again as our key name, and our default value is 0.05 as always. Then when we set, we want to do player prefs.setFloat, once again storing it into text delay, and here we can use the keyword values, which represents, so if you do settings.textDelay equals to 0.1, for example, value will be 0.1. It's just whatever input you got for setting. So now if we run the scene, you should see that this slider still works as before. But now if we stop the scene and then start it again, you'll notice that the starting position of the slider and the text delay was what we set it to before. So if we set it to instant, the next time we play, it will also still be instant. Okay, but now here's time for pop quiz number 2. Even though we didn't change our code in any other classes, what side effect does our settings.textDelay property have? Take a minute to think about it, pausing the recording if needed. Okay, so because player prefs reads and writes to a file, it's actually quite slow. So in our typewriter, each time we want to print a new character, so every whatever delay it was, we're checking the value of player prefs, which needs to go to a file in your computer, which is obviously quite slow. So to help to mitigate this, we can use our next topic, events. So events allow you to register functions to be called when you invoke the event. So you can think of this sort of like subscribing to a newspaper. When some noteworthy news event happens, the newspaper will deliver that to you in the form of a news, and then you can react to the news. So events are great for encapsulation because this allows you to separate the code that detects or triggers changes from the code that reacts to those changes. In terms of Unity programming, there's actually 3 different options for your events. So the first option is delegates, which are a C# feature. Delegates are the most flexible of our 3 options, but they're also the most dangerous because they let you do things that may not be what you want to do. For example, like in our newspaper example, if you use the delegate, you could overwrite the list of people who are subscribed to your newspaper, which is sometimes what you want to do, but not most of the time. So therefore, C# has events built on top of delegates. So C# events prevent you from doing things like overriding the list of subscribers, which provides additional protection, but obviously this means C# events are slightly less flexible than delegates. Finally, there are Unity events. So Unity events are like C# events, but also much slower. But the one good point they have is that they have editor integration. So if you've seen earlier, you may have seen that buttons have an on-click where you can add functions to be called, and Slider has the on-value changed where you can add functions to be called. Those are Unity events. So if you use Unity events, you can do drag and drop for your functions. So for this tutorial, I'll be coding with Unity events, but there are also solutions provided in the repo that use C# events and delegates if you're curious. You can also find documentation on all 3 of these online. So let us go and add an event to settings. So we want the typewriter script to only update its local value of delay when this global value of text delay changes. So first, since we're using Unity events, we need to add the Unity engine.events namespace. To declare an event, we can use public static Unity event. And in this case, Unity events are coded so you can use generic types. So here we can use float, since we want to have our event functions that are called by this event take a float. And we want to call this event on text delay changed. And then we can initialize this to be a new Unity event of float type. So here in our set function, we can, since the value of text delay has now changed, we can do on text delay changed dot invoke. So invoke is the function that you use to trigger all of the functions that are subscribed to this event. And here we want to provide them with the value that it changed to. So let's go and change our typewriter script. So once again, we actually do want to store this float, but we no longer want to have a default value there or have it be serialized field. Instead, we will initialize this value in awake. So now this typewriter will only get this delay value from player press at the start of the scene once. Instead, here we are going to write a private function that takes let's call it update delay, and obviously it takes the float new delay, and we can set our delay to the new delay. So here at the start we also want to subscribe to so we can do settings dot on text delay changed dot add listener. So we want to update our delay whenever the delay changes. So now we can change settings.text delay to just a local copy of delay and save our script. Now if we play, the functionality should remain the same, but we should no longer we're no longer calling player press all of the time. Great. And notice how text delay slider was encapsulated, or settings was encapsulated well enough that we didn't have to make any changes to text delay slider. And now in the future, if we have a different script that needs to know the value of text delay, it can also use this method to get the text delay only when it changes. One thing that we do want to add though is, because this settings class is static and this event is static, this event won't get destroyed on the next scene, even though this typewriter will be destroyed. Which means, since we subscribe to this event will still be storing this typewriter even into the next scene. So instead, we want to add when the script is destroyed. So Unity calls on destroy when the script is destroyed, and we can clean up after ourselves by doing settings.onTextDelay change remove listener instead of add listener. We can remove update delay. So now at the end of the scene, when this typewriter script is destroyed, it will remove itself from the onTextDelay changed event, so that when the next scene starts, onTextDelay changed will be empty. Alright, we're getting close to finishing up this mini project. So let's discuss Unity attributes. So we've already been using serialized field, but there's actually quite a few other useful attributes that Unity provides. So first of all, there's require component. Require component makes it so that it allows you to specify component dependencies. So let me just show you. So for example, here we know that text delay slider always wants to be attached to a game object that actually has a slider. So we can do require component and then specify we want this component to be a slider. So let's create a empty object. So now if we try to attach our text delay slider script to an object that doesn't have a slider on it, Unity will automatically create the slider component for us, so that we don't have to remember to create a slider first. Similarly, if we try to remove the slider, Unity will complain that we actually do need the slider and you're not allowed to remove it unless you remove this text delay slider script first. So it's very handy for not requiring you to remember all of your component dependencies. Similarly, we have this disallow multiple component script attribute, which we can add here. Disallow multiple components prevents you from adding multiple copies of the same script to the same game object. So if we try to add a second text delay slider script to the slider, Unity will tell you that's not allowed. So this is useful for any script that you write that you don't want to accidentally attach two copies of, for example. So, for example, we don't want our typewriter to be competing to change the same text mesh. So we can do disallow multiple component. So there's only ever one typewriter that's affecting this text mesh pro. And of course, we also want to actually require that typewriters go on text mesh pro components. One neat feature of these attributes like disallow multiple component is that if you inherit from a class that has, for example, disallow multiple component, the child classes will also still respect this. So if you have, say, typewriter version A, typewriter version B, if you already have a typewriter version A attached, and then you try to add a typewriter version B, Unity will also warn you that that's not allowed and prevent you from making mistakes that way. Okay, there's also the range attribute. So you can place this before a variable to indicate what the valid range that you can put in via the editor is. So for example, you can prevent people from putting in -3.5 for the delay between characters by setting the range to be 0 to 1, for example. And there's also the header attribute, which lets you put a separate your public and serialized field attributes or serialized field variables with headers. So if you see here, well, let me try and find one. All right, so now if we take a look at our script, see we can separate our public and serialized field variables with these sort of section names. There's quite a few other attributes that Unity has. You can find them in the documentation here, although there are also some other attributes like serializable that are annoyingly found elsewhere in the documentation. Unity documentation sucks. But I also managed to find this possibly complete list. I don't know whether it's actually complete, but someone wrote a GitHub script or someone posted their script onto GitHub, which like finds all of these attributes. So it's probably complete, but you know, you can use that as a reference as well. Okay, let's wrap up with console and debug. So you probably have already used debug.log a lot to figure out why your scripts aren't working the way you expect them to. But did you know that you can also, besides printing out strings, you can concatenate messages with the plus operator? So you can, for example, print out the text delay and the actual value of the delay using in debug.log. Debug.log also actually supports rich text markup, so you can make your console messages look fancy with different colors or bold or strike-through text. Debug also has several related functions like debug.log error, debug.log warning, and debug.log exception, as shown in this little code snippet. So you can log your messages as errors, warnings, or exceptions explicitly instead of just saying like debug.log open quotation mark warning, you're doing something wrong. You can actually have it like show up with a little warning icon. And finally, you can actually use debug.assert to not only do an assertion, but also print out a message if the assertion fails. So this is doubly useful for debugging your code. Alright, finally, you should remember to actually comment out debug messages that you're not using once you're done debugging, because if you leave those in, it makes it and spam the console full of irrelevant messages. When someone else is trying to debug, it makes it harder for them to find the messages that they're looking for and slows down the debugging process. So just remember to comment them out. You can always uncomment them if the bug reappears. Hopefully they don't. Alright, thanks for coming. I hope you learned a lot in this tutorial, and have a nice day.